All right. We have some interesting stuff to go over tonight. We have any folks who's this is their first meeting or who haven't introduced themselves before?
That's me. Well,
And you
me.
are, oh,
Oh, yeah.
ah,
Yeah. I'm Robert Williams, Bob Williams. Yeah. I've met Greg. I'm sitting around with my hyperstars and trying to figure out, get the nerve to put it on my telescope right now. But yeah, so
well,
I thought
welcome
I
to the group. You're in the right place.
Welcome, Bob.
thank you, thank you.
Anybody else new? Well, we usually dedicate the first few minutes of each meeting to the beginners. So if you'd like to admit you're a beginner and you have a question, this is the time to bring that question up. There's no stupid questions, only stupid people. So, any questions? Any beginners? Yeah, Bob.
I, I'll. I mean, I'm just getting started. I mean, this has been a year-long project, and I've got Nina running on my computer out in my observatory, and I keep running across more things like was it
No
Hocus
ouch.
Pocus and things like that. All these things that I should add on,
No
and
ouch. No
should I
ouch.
basically try to just take a picture before I start doing anything too. It's not quite so frustrating.
So Bob, the plugins like Hocus Focus, all to my knowledge, work fine.
Hmm.
And you should, if there's a problem with one, you can uninstall it. I did have a problem where it was crashing my computer. I was something I was just playing with, but
Yeah.
Hocus Focus works fine. It's actually a substantial improvement to the regular focusing mechanism within Nina. Um, if you want to ping me or send me an email with what you think you want to add,
Mhm.
we can set up a call offline to talk through that. I probably have 10 of those plugins installed, and I probably use five or six of them regularly.
Okay. Thank you.
Does that help, Bob?
Yeah, it sure helps. I mean, I'm just looking at all the pictures you guys are putting online, and they're so incredible. And I'm trying to just take a, I feel like I'm not worthy, but that's okay. It's what I've been seeing in the forum. It's just been absolutely
No,
incredible with what.
Bob, the first couple of these meetings that I sat through, I felt like a high school kid who hadn't finished algebra who had walked into a second year calculus class. Everything was going way up here. Um, Stick with it, and all of a sudden you say, "Oh, wait a minute! I understand what they're talking about. That makes sense."
All right.
And
Well,
the
Bob,
images will come along.
which hyperstar do you have, Bob?
it's it's for the 11 inch. I'm not sure which model it is. I don't know if you can see it on the.
Yes.
It's
Yeah, similar to the one I have for the 8.
yeah. It's I've got an 11 inch in my observatory, but
Okay,
I put
great.
a I've got it sitting here, and now I've got to put it on my telescope.
Yeah, I would say putting it on and taking off the first time is it's kind of a process you got to learn. And once you drop it the first time, it's no big deal. I'm just kidding.
You drop it the first.
You don't want to drop it, but I do not take the camera off of it. That would be my suggestion, and make sure that's not on the device first before you put it on.
Yeah.
Uh, and then gravity is your friend. So as long as your scope is sitting upright and you get on to the point, I'm not sure how big your mount is or whatever, but just carefully screw it in and don't thread it too tight, and I think you'll be fine.
Okay.
David, when you're saying upright, you're suggesting pointing it straight up, right?
Straight
So,
straight up is best.
yeah.
Could have it at a slight angle, but you want it to be plumb. So kind of like when I put my rig on the back of my scope, I found that if I point the C8 down, as opposed to just kind of levering it in there horizontally, I get a more plumb fit. It's straight, and my stars look a lot better when I'm trying to focus. So
So I'm better off putting the hyperstar and trying to polar align it using the 3-star alignment through Nina than I would be trying to put the camera in the back of the telescope. Is that right?
well, with the hyperstar, what you're doing is you're increasing you're reducing the focal or the aperture of the scope.
Right.
Um, so I think I'm not sure, but I think it might be getting to f2
I
with
think
your
so.
particular scope or close to it. With my C8, it's about 1.9 technically. And you're also reducing the field of view. With my C8, the native focal length is around 2300, I believe, and it brings it down to like 390. So you can get a wider field of view. And you're bringing a lot more data. It's like a Raza, except you have the ability of shooting from the back of the image train as well, but you're going to have to shoot around f7 and I'm not sure what it is like with the C11, might be more
Yeah.
than that. And you're going to reduce your field of view as well dramatically.
Right. I understand.
Yeah.
Hey, Bob, your mount is already in the observatory. It's probably already polar aligned, right? You hadn't used it before?
I used it and then something got screwed up and the telescope started pointing straight down. And then I don't
But
know.
the mount didn't change, right?
Yeah, that's not polar alignment. That sounds like a negative on your latitude or something.
Yeah.
Yeah, well, I was fooling around with the mount to try to get it, aim it
Yeah,
towards Polaris again, and then when it went to home position, it didn't go. It wasn't shooting to Polaris. So I need to align it again, which is another one of the step-by-step things. It's
right.
3 steps forward and 4 steps backwards, I think is what.
Yeah, but at least you get it aligned once and you lock it down and you're done.
Yeah,
As
that's what I
opposed to
understand.
a setup and tear down people who, we're aligning night after night.
Yeah, I mean, I've got the observatory belt now, and the dome is rotating, and the shutter is opening.
Very good.
So things are getting better.
All right. Well, you've got lots of expertise here that you can call on. Just drop email in the TAA forum. You'll get responses.
Okay, thanks. I appreciate it.
Any other questions?
I have a question for you guys. I
Okay.
should probably start my video, right? Can you see me? There I am.
There you are.
Cool. So I have to share my very first astrophoto that I've ever taken with my rig where everything worked. Everything was together. So I know it's a pain in the neck for me to find photos, but I have an EQ6R and a C11, and my camera's a 533 MC. And there it is, the very first one right there. It took me a while to get the telescope to slew to that. It was off by about 20 minutes from the position that the star catalog said it was supposed to be in. So my question is this: once you get pointed at the object at the RA that it's supposed to be, how do you sync that with the mount? I'm using Green Swamp server between the mount and Nina, but I don't know how to sync it so that, as I align on stars and such, the mount learns, hey, this is where I should be pointed, and this is where Nina thinks I'm pointed. So anything you guys could give me for advice would be helpful. And if I need to take this offline, I'm happy to do that.
Yeah, Jim, I think we started that conversation. I did not have my computer handy, but I believe there is a setting in Nina to following a plate solve to sync the coordinates.
Yeah, you
back
see
to the
that
mount.
under the mount options, I believe.
I've looked, and the only thing that I could find to sync is the date and time and lat long from Nina to the mount, or from the mount to Nina. I haven't found anything about synchronizing what the plate solve did, so I'm kind of stuck there. That's where I'm at. But yes, Jeff, you've been working on several different topics with me, including autofocus, and I'm going to give that a shot when I get back to Tucson.
right.
But
Okay.
McCann says it's in the plate solve section.
Yeah, the plate solve section. All right, not the mount. All right. Well, let's have our main presenters get started here because this is an interesting topic that everybody's probably interested in. So Jeff and Craig, whenever you guys are ready, you got it.
All right. Okay, so we're going to talk about culling subframes. And I'm Jeff Rothstein. My partner is Craig Harding.
Right here.
You can ask about this parenthetical here in the questions because we experimented with asking AI questions about how we should organize this. I would venture to say that there is not a word in this deck that was given to us by directly by AI, but it's kind of helpful to help us think some stuff through. That's the big picture. So tonight's program is brought to you by the number, the square root of x, and by the letter O. And a word from our friend Oscar. And that's our theme for the evening, to a point. So here's what we're going to talk about. Why should you cull subframes? You know, taking a whole night of data, why not integrate everything? What are the strategies for culling? What are the ways to approach it conceptually and think about it? And then what tools can you use and what workflows? And even how do you use some of these things? And we'll talk about some of the more familiar options. Right?
So why are we calling the subframes? And Jeff, you mentioned something that a lot of us, when we first started, were used to doing. It's like, oh, I got all this data, or I don't have much data. I need to use it all, except the things that are most obviously wrong. But the first reason to call subframes is to improve the signal to noise ratio. And really, it's more a focus on getting rid of the noise. And as we'll talk about later, there's some balancing going on there. You don't want to, if you don't have enough integration, you don't want to call so much that now you're reducing too much of the signal. So really to improve that signal to noise ratio and get the noisiest of the frames out of there. Another reason is to get better clarity, image sharpness, not only of the stars, but think about the nebulosity and the structure in galaxies and things like that. There's tools that will help you to improve the sharpness of the stars, and to a certain degree, they work on the nebulosity. But if the nebulosity is smudged, you can't fix everything. So getting rid of the marginal frames will help with creating a better and clearer image. Getting rid of some of the artifacts, that come through in processing. So, I've had yeah, a lot of times some of the little satellite trails get managed out, with averaging and some of the cosmetic correction utilities available. They get managed out. But I've had satellite trails, maybe it's an airplane, I don't know. I've had things show up in my final stack. So, going through and looking for egregious frames that might produce significant artifacts is something you want to do. Color modeling, if you get these next couple of ones are all color modeling and natural appearance are kind of related. It's back to, if you've got a lot of clouds floating through and they affect the color balance or the background noise or things like that. It can affect really what other tools can identify as being something you want to keep versus noise. So again, getting back kind of to signal to noise, if you got too much noise, some of the signal gets washed out in that too. And then for some people, reducing the processing time. I know Jeff's got a 6200. I think his is a mono. I've got a 6200 color. And those frames are like 120 meg each. So, when you start capturing a lot of that data, and depending on the processing tools you have, it can, pushing those bad frames through there too just prolongs the process. What's the risk of overcalling? Well, I kind of mentioned it before, especially if you don't have a lot of integration time, you don't want to overcall because now you risk reducing that signal more than reducing the noise. You need enough signal there to get a decent image. If you overcall, you also might discard some data that the stacking tools will help fix through weighting or um, um, cosmetic correction or things like that. So we really suggest that you take a cautious approach to calling when you've got smaller data sets. And to kind of show that a little bit more obviously, Jeff's going to walk through a graph of it.
The red curve here shows the law of diminishing returns as we gather more and more integration time. At low levels of integration time, the change in integration time significantly increases signal to noise ratio on the y-axis. But as we get way out to the right here with lots and lots of integration time, the same sized change in integration time makes very little difference on the y-axis. Think what this means for culling. If you have a large data set and you cull, let's say, 10 frames, the change in signal to noise ratio will be modest. But if you have a small data set and you cull the same number of frames, there's a significant reduction in SNR.
Now, the blue line here bear in mind, is not showing you what the y-axis is for a given value of x on the curve. This is actually the slope of the curve at any given point. So it's showing you the change in the y-axis for a given change in the x-axis. We were trying to avoid diving into math. But if you want more information, I've got another presentation of this chart that I can show you after we're done. But the key point here is the more data you have to begin with, the more ability you have to cull without drastically changing your SNR. But if you've got little data, then each time you remove a frame, your SNR is going to drop more.
The red curve here.
We've covered the first couple of bullet points here. The important thing is you start thinking about the question, okay, so how many frames can I take out if I've collected 3 hours of data versus 20 hours of data? And the answer is there is no objective test. You can't say you can take X% at this amount of time and Y% at that amount of time. It depends on so many different variables. So the best advice we can give is to come at it the other way. Figure out how much integration time you need. If you're shooting one-shot color, it's the total amount. If you're shooting mono, you got to think channel by channel. Decide what you're going to get, and then shoot and cull until you hit your target time. And that means looking at your data on a daily basis so that you can figure out, okay, I shot 80 frames last night. How many of them were actually good? And how much does that advance me toward my total integration time goal? And we'll talk about that a little more in just a few minutes.
So types of frames to call, the obvious ones, the ones you would just walk through and look at the images before you start doing any statistical analysis. Uh, Clouds, you just sitting there using tools like Blink or some other viewer and look for clouds that would, really affect the end result. Start satellite trails or plane trails. Like I said before, if I come across one that's really big, or even a frame that's sometimes, if I'm shooting in the Orion area, uh, it's almost like every frame's got a satellite trail in it. But I'll look for the ones that got three or four in it and maybe call those out, especially if the rest of the statistics about it are bad. So, obvious defects. Um, High full width half maximum. I mean, if you just got some bloated stars that might have been from guiding, maybe the scope was bouncing around, maybe it's seeing conditions, whatever it might be, look for those because you're going to find, a certain amount of them that are just outside of the norm. And then eccentricity. If you got elongated stars, significantly elongated stars, some of that can be fixed by the tools out there that we'll talk about later on, and most of like Blur Exterminator. But um, if they're really bad, you got to also think about what's that doing to the blurriness of the nebulosity that I want to keep, because sometimes you can fix stars, but that doesn't mean it's going to completely fix the rest of the image. Um, so let's move on to the next one. BXT. So that was a little bit of a lead into BXT, Blur Exterminator. Um, I don't know what everybody's using here to process, but it's one of the beautiful tools out there that fixes a lot of evils. And there are a lot of people that will not call and stack everything. And for stars, it'll fix a lot of things that come from either guiding area or some optical aberrations like coma or on the edge of a full frame camera where you've got some wonky stars. It'll fix a lot of that. Even help you with some poor seeing conditions where the stars were a little bit bloated. It'll tighten them up to a normalized PSF, and then you can shrink them. But again, sometimes it can't take care of the artifacts that are left by clouds or star trails, or getting back to signal and noise, and how a high noise level, the ones you didn't call that had a high noise level, might blur out or override the signal that's really there. So BXT can't fix that. So again, using BXT in combination with a logical calling thought process, I've found myself I'm somewhere between 10 and 20% in terms of the amount of frames I call, but they become real obvious when you start to look at the statistics. And then keep the marginal frames. Don't go too far if you're, using Blur Exterminator, and let the stacking software kind of help control how much each frame adds to the overall stack. So those kind of counterbalance the calling. Next frame. Oh, I got this one.
Still
Sorry.
you.
I was waiting for you to kick in there, Jeff. Um, so weighting tools. Really, there's a couple of, we're going to talk both about PixInsight and AstroPixel Processor here. So in the last slide, I talked about letting the stacking tools and or the measurement tools give you data to understand either what to stack or what to cull, or when you go to stacking, how should it use this data to determine how much each image should give to the overall stack. So PixInsight seems the most common, and the one they suggest using is the PSF signal weight. But they've got other weighting options in the stacking utility, and then within that, within PixInsight, and we'll talk about this in a little bit, the subframe selector has got even more weighting options to look at what frames do I keep or discard. Similarly, AstroPixel Processor, which I use a lot of times to analyze my subframes, it's got a quality score that kind of combines the rest of these metrics here. Or you can just look at SNR, noise, star density, eccentricity. When you're actually looking at which ones to call, there's a few more measurements like background noise and I can't remember the other ones now. But I like AstroPixel Processor because it lets me delete the bad frames that I don't want to process. I mean, when I go through this and I decide what I don't want it. So it makes it easy to delete it. But those are some of the options in terms of waiting for both culling and for stacking. Next frame.
So what we're going to do, you got,
Go. Go ahead, Jeff.
okay. So these are the tools that that are available for culling with in three example programs. PixInsight, you've got the blink tool, which allows you to click through or play a little movie and let the problems jump out at you. And you can also use subframe selector. Just to supplement something that Craig just said, PixInsight, the term they use is their processing is non-destructive. So you have to take a few steps if you actually want to delete some data. APP, I think Craig has just talked about. There is a new kid on the block, the SETI Astro Suite from Frank Merrick. Merrick has created some excellent individual processing tools. He's now creating an overall processing suite that includes a tool called Blink Comparator, which we'll take a quick look at in just a couple more slides. But I believe other programs such as Cyril also, and this is an element of astro processing that's necessary. So I think you'll find these things in whatever program you're using. Now we want to get into some demos, and rather than jump to our computers and hope that the computers don't freeze up, we've pre-recorded all these, so these are going to be videos. But again, happy to answer questions as we get to the end. So we'll start with subframe selector in PixInsight.
When you open Subframe Selector, you will see this dialog box. For now, we're going to set it to measure subframes. Add your frames here, add system parameters here, a region of interest if you wish to, and then execute. Once the process is done, two additional boxes will open. The first box here reports all the measurements that Subframe Selector has taken in a table here and in two graphs here. The second box allows you to write simple expressions to approve or weight your frames. You will spend most of your time in the measurements box. Here, you can sort your frames on any of the many parameters that have been measured. You're starting with PSF signal weight, a proprietary PI tool that they recommend as a standard mechanism for weighting your frames. And you can sort ascending or descending. This can be useful for selecting a reference frame because you can quickly find your very best frame for any parameter. This graph allows you to compare any two measured properties. Here, FWHM in blue, the primary graph, and PSF signal weight in the dotted gray, the secondary parameter. There's a lot of information in this graph. You can see that FWHM in these images ranges from 1.8 to 3.6, and that PSF signal weight ranges from 0.1 to 0.24. The black line here shows the median for the given primary property, and the dark gray bar is one standard deviation, while light gray measures two standard deviations from the median. The right-hand graph shows a histogram for the particular primary property, and it will change as you change the property here. There are two ways to exclude data from your data set. The first is to simply click on a frame that you wish to remove, like that. The red X means it's out. The other option is to write a simple expression for what you want to remove. In this case, let's say we want to keep all eccentricity that is less than 0.52, which is about the second deviation. There it is. You can continue this process with other properties. When you're done, depending where you are in your workflow, you can either output the approved frames, in other words, everything without an X, by using the output subframes feature over here. Or if you're checking your nightly frames, notice right here, you see the percentage of approved frames, 80%. Factor that into your overall goal of integration time that you're working for and plan accordingly.
Craig, any introduction before I press the run button?
No, AstroPixel processor. I guess what I'll say is when you look at this screen, basically all you got to do is run the lights. You don't have to calibrate them really, or I don't. I'm looking for other information that doesn't require calibrated frames. So just load lights, click on the normalize, run the normalize, which goes fairly quick in AstroPixel processor. You get a graph up there of, I think what I did is I'm only plotting their quality score, their full width half maximum, and their star eccentricity. And then on the right-hand side, you see basically the eccentricity or the star shape being shown. So you can see the star on the bottom right where you get a good graphic of the eccentricity, and the little bell curve above that is the widest full width half max of that and the narrowest. So graphically, you can see the difference in in the roundness. So that's the only lead in I think I need.
Okay.
An AstroPixel processor, to call frames, you simply load them first. And in this case, I'm loading data from a CPC 1100 with a Hyperstar and 183 MC Pro that we were starting to set up for use out at CAC. It intentionally or I know it has bad data, so that's why I'm using it. And what I've done is load those frames. All you got to do is then go to normalize, click normalize light. You don't need any kind of calibration frames, don't really care about that. It will then go through and score them all and then give you a graph of the data. In this case, on that graph, I actually just am showing the quality score, the star shape or eccentricity, and the star full width half max. The quality score actually takes a lot of these other measurements into account when it comes up with its score. So it is a multi-valued score. I will immediately, though, go to the quality score, rank it from worst to best, and then start to call from there. You know, you might decide this has got so much bad data in it, but even if I just wanted to take the bottom 10 or 15 off, I just go to the top of the list, which is this worst item, and select, let's just say I want to get rid of about the first 8. And then I can either remove them from the list. So I want to process them. I don't want to delete the data, or as I normally do, I just delete it. If it's bad, I don't want it. Move on to the next one, star shape. This one's really easy to see that, you know, somewhere probably about here down, I would definitely remove as a first pass. Again, same thing. You just go to the top of the list. It's now sorted by star shape. Select however many you want to get rid of and hit delete. And then similarly with full width half max, you can see that it drops off significantly here. So this has got a lot of bad data. It really shows, you know, how you can easily go through and call. Even when I've got good data, there's always a slope. You know, it's not going to be dropping off so quick, but a slope up here of where I got good data, and then you're just going to have some bad ones. And that's what I focus on, getting rid of the bad ones. The other thing that's really nice here is the graph over on the right. It shows you the full width half max of that frame, the quality score, but it also gives you a PSF cross section on and a view of the PSF contour map. So if I select one of the really bad images, let's see which one I want to select. Get it to load it. There we go. You can start to see the star shape and use that as a way to get rid of frames. I think that's the worst frame in the whole batch. You can see that it's got a horrible shape. So these are the tools that are available within Astral Pixel Processor.
This one, there's no audio, so I will just talk over it. This is the SETI Astro blink comparator frame metrics screen. And Craig and I both like it because of the graphical user interface. So I'm going to start running this, but you've got red lines that are at one extreme or another. And as you draw down, as I've done here, on FWHM, it begins excluding the worst frame and then more down to whatever level I choose. As I make the change here, you'll see that dots will turn red in the other properties, so that you can see if you exclude something from FWHM, how does it affect the other sets? Now, you only do have the choice of these 4 properties, I believe. I'm not a SETI Astro Suite user. So here I'm mousing over the other frames, or the other properties, and then you can adjust the other properties as you see fit, and that too will then reflect changes to each of the other 3. And it's, you know, star count doesn't start high, it starts low, and so you raise that up to eliminate your weakest frames.
Hey, Jeff, this is Dave. I have a question because this is something that's of interest to me. I've seen some really good reviews about it online. How do you determine what your value should be, especially like full width half mass? What's the number that you look at from a
And,
stand?
and we're coming to that.
Okay, great.
Bear with us, just another slide or two.
Okay, I'll hang on.
Well, just another slide. So now we're going to, because we anticipated the question, okay, what should my FWHM threshold be? What should my eccentricity threshold be? So there's a lot of content on this slide. And for starters, I think we believe you should be using some sort of visual tool, Blink, ASI Fits Viewer, or the equivalent, because for all the data, your eyes are an exceptionally good culling tool. I believe Greg told me he does not use things like Subframe Selector. He just goes through his frames very carefully, and if he sees defects, they're gone. And in fact, if you read, if we were preparing this deck, I was going through PixInsight forums and the manuals and books. And PixInsight's position is that you don't need Subframe Selector if you have done a good, if you can't see a defect, you probably shouldn't be throwing it out with Subframe Selector, I think would be their characterization. So number one, look. And when I do Blink, I start with the whole frame because I'm looking for the gross defects in the entire frame. Then I'll go through the set a second time, zoomed in on either a star field or whatever the target is that where I can get a decent view, looking for finer grained defects. Now, where do you set your metrics, whether you're setting the bars in SETI Astro Suite or Subframe Selector? So, David, let's start with your question. What FWHM should I use? And the best answer that I can give you is it depends on what rig you're using and your skies. I have a 105 millimeter refractor. My FWHM is going to be bigger than a C8s or a C11s because of the laws of optics and physics. And I'm in Oro Valley. I'm a little bit west of the mountains. Our location is going to affect seeing. But over time, imaging night after night, we're going to start to get a feel, we all should, of what a good FWHM or expected FWHM looks like for my rig under my skies. And I think striving to have a sense of what a good number is. And you can see that looking at the data in Subframe Selector night after night after night. If you're used to seeing, I'm making up numbers here, FWHM of 2.5 to 3, and you have a night where they're all 5, you probably have a set of data you should throw away. I think you can be a little more objective with eccentricity. I've got two numbers here, 0.42 and 0.60. I've seen both of those online as thresholds for eccentricity. I think if you are looking at an image without magnification, it is very difficult to see eccentricity that is below 0.6. I find, though, that if I pixel peep, I can definitely see eccentricity at 0.6 down into the 5s. Below 0.42, I understand it is very difficult to see eccentricity. And the closer you get to 0.42, the more you can be confident if you're using Blur Exterminator, this is something BXT can fix. There's all sorts of statistical reasons why you don't want a lot of things at the far end of your bell curve, but I think you can scooch it a little bit upward if you're using Blur Exterminator. Stars and PSF signal weight, I do not know of any standard that just, look, you're pointing at the center of the Milky Way. I've had frames where PixInsight says there's 25,000 stars in the frame. I've had frames pointing during galaxy season where there's 600 stars in the frame. So I think you really have to be looking at relative performance. And for that, the standard deviation bars can be very helpful. Just as a refresher, in a normal perfect bell curve, which of course we know all of our data is perfect normal bell curves, one standard deviation captures about 68% of the data. Two standard deviations captures about 95%. So flipped around, if you're keeping data of greater than two standard deviations, you're keeping some of your lowest 5% of data. So I think, again, experimentation and looking at your images will ultimately, I think, lead you to techniques for weighting these things. One other comment about looking at your images. Both AstroPixel processor, Craig showed you how you can get a visual on stars. In PixInsight, you can double click on any of the frames that you're analyzing. Open the frame, you can scroll around, you can zoom in. One of the best teaching tools that I found is when you see something that looks like an outlier, look at the image and maybe compare it to a good one. And you start to get a sense of, oh yeah, that's way off, or boy, I really don't see a difference there. So I think it's really worthwhile to use your eyes wherever you can. Craig, you want to add here?
Well, eccentricity, I know when I'm running things through Subframe Selector or other tools, I don't take anything above zero point 0.6. I haven't gone all the way down to 0.42, but I've been in the 0.55 range too. So it's getting rid of stuff, but maybe not overcalling. At that point, I guess I am sort of relying on Blur Exterminator to fix some stuff. As you said, stars, it's really a relative thing. You're comparing frame to frame to frame. So when you're looking at it, maybe you're going to take, if you see a drop off all of a sudden of some frames that have a significantly lower star count, those are the ones you're going to want to look at more and see what's going on. So those are the candidates for that. And then, as Jeff was saying, knowing your setups, full width half max for your location, and keeping that in the back of your head. Do I have good data or crappy data? Do I have really poor seeing? What's going on? So that's all I have to add.
David, does this start to answer that question?
Yeah, it does. I've only been using Blink primarily. And I found, at least with my settings in WBPP, that it's either spot on or maybe I missed a couple. But if I don't blink the data and I just dump it into WBPP, I'll get more rejects as I'm filtering it through WBPP. And in addition, one thing, I don't know if you're experienced or not, maybe it's just my computer system, but if I have a lot of bad frames and I haven't blinked my images, I found it can actually stall or crash WBPP in its processing. So I find if I've culled it properly and I've gotten rid of the visual rejects and I've come pretty darn close to being accurate, at least for my eyes, then the same group of data, with the exception of the rejects that I found through Blink, will go through and the system will work fine. But if I try to run it without doing the blink and I'm lazy, it can actually stall the whole thing.
Interesting. Thanks.
And speaking of just keeping data and knowing your data, I know Doug, who's on this call, Doug Summers. He always has a lot of pertinent data about every one of his stacked images, including full width half max, and I forget what it. I always see you when you publish images, Doug. You have a lot of details about um, how this thing's stacked out.
Yeah, I'm using the other category of your tools, which is a CCD inspector I use for the frames, but it's very much like Subframe Selector, essentially the same kinds of information.
So in trying to pull all of this together, I think the takeaways are, and thank you to Doug for this advice. The first bullet was something that Doug suggested. Thinking about this from the bottom up instead of the top down. Figure out your integration time and work toward that. Inspect visually, and remove visually defective subs. Use subframe selector to check your nightlies. And when I say subframe selector, I mean that class of tool. You can also use it for culling. The weighting algorithms will allow you to keep somewhat marginal frame, not bad, but just a little bit outside of where you'd like them to be, and it will weight them less than the better frames in producing the final image. If you remember the video about subframe selector that we just looked at, the range went from 0.1 to 0.24, and that's just some made up, whatever the proprietary formula is. But it shows you that some of the frames are going to get 2.4 times the weight of other frames. And that was actually a pretty good data set. I have had ranges of 5, 6, 7x from bottom to top. There's a place for BXT in this process. To Craig's point about the 6200, my 6200 is not properly set for back focus. So the stars at the perimeter are triangles, and that BXT can do. It fixes them perfectly. But putting this all together, cull, weight, and run BXT together, we think can produce better images overall. So that is our presentation. We are happy to answer questions. Tell us things we missed. Tell us things we did wrong.
Well, I'll ask you a question. How important is it to pick the reference image?
Well, it is important. And for those like Bob, if you're just getting started in the hobby, when you stack the images, you pick a reference image, and then all the other images are matched to it. So you want that to be a high quality image. You want it to have a lot of stars. You don't want it to have significant defects. Now, I have a very simple way of picking the reference image. I let WBPP do it. And I've just never had a reason to suspect it wasn't doing a good job. It is using the kind of data that we saw in subframe selector to select the best image. And in fact, if you're doing mono, it will take a single reference image, maybe it's a red image, and it'll stack all the luminance, all the reds, all the greens, all the blues to that one image so that you can then ultimately bring them all together. Craig, you want to comment?
I do the same thing both in a weighted batch pre-processing in PixInsight, and when I was stacking an AstroPixel processor, they have you can pick what measurement you want to pick a reference frame. I'm not even sure whether it's using the our scoring weighting tool as the choice for the reference frame, or it's doing more math. But I've just let WBPP do it, and it seems like it does an excellent job.
And you do have the option within WBPP is weighted batch pre-processing. You do have the option of selecting the reference frame manually. And you can do that using subframe selector. If I were to do it, I would probably give stars a lot of weight. The frame that has the most stars, I think, would be, and I would look at them, but I would think the frame with the most stars would be a good candidate for a reference frame if it otherwise was of good quality.
I have a little thing to say about SETI Astro.
Yeah.
the culling on that. That's what I use because I love the graphical. One thing I found myself doing, probably just from an experience, is that you have to be careful because no matter how good your set is, graphically, it's almost always going to look the same when it comes up. Because if you have better information, it's just going to zoom in farther. And so you have to make sure you look at the numbers on the left-hand side. You understand what I'm saying? Because graphically, it's going to fill up from top to bottom. And so you may
Oh,
start.
yeah. So you could have full width half max going from 2.1 to 2.2 or from 1 to 6.
Exactly.
And the graph will
So
look the
you need to
same.
make sure you look at the numbers first, which is I didn't do sometimes because I thought I had better set that I look at the numbers and I think, oh, it just zooms in. It just zooms in on it, so it's going to fill it top to bottom regardless of what you do.
Right.
So, but that's just a thing about SETI Astro Suite.
I like the SETI Astro tools because they put the graph bar, the bar you slide on the bad end of the data. So I sometimes I find with different measurements, I got to think is a bigger number better or a bigger number worse?
Yeah.
And I got to kind of take a moment to think about it. But with SETI Astro, it's right there.
Well, yeah, the only one that's different is the star count. That's the one that goes up. All the rest of them
Right,
go
it's
down.
at the bottom, yeah. But it's on the side of what you would want to call.
Yeah, exactly. Right.
Yeah.
Other questions, comments? Okay, guys. Well, I think you've pretty well covered most of what the questions were.
I think Doug Davis was going to ask something, but I'm not sure.
Yeah, if I can figure out how to unmute this thing.
Yeah, yeah. Go for it.
Quick question about Blink. Is there a way in Blink to actually delete the frames that you don't wish to use?
Absolutely. There's a little bar of icons along the bottom.
Yep.
Well, so it's not a direct delete. Going back to the point that Pix Insight is quote unquote non-destructive.
Right.
You can move toward the right-hand side. You can move an image or a group of images to another folder. I have a folder I call rejects. And I transfer them there, and then periodically I dump that folder out. I suppose you could select as your other folder the recycle bin. And then your images would be deleted the next time you emptied the recycle bin.
So is the box you're suggesting, is that the one that says copy selected files to a new location?
Not copy, move.
Yeah, and what I do when I'm going through Blink is there's a little checkbox next to each image. What you do is you uncheck it. So as you come up to an image you want to reject, just go through them. And as you see a bad one, like say the stars are elongated, you can just hit that checkbox and then come back to it later after you've gone through, say, 70 images or whatever you've done, and you reviewed. And then I just highlight using the control key on my keyboard each one that I've unchecked, and then you can go ahead and move those to a different folder. And I usually have a folder on my hard drive called rejects that I'll move them to without permanently deleting them at first.
Ah.
But you
Okay.
get some way of noting which ones you want to reject. You can't just go through and say that's a bad one, that's a bad one, and then have to move each one individually. That would take a long time. But I find by unchecking each one and then highlighting them together as a group, it makes it a lot easier.
Thanks.
Okay, other questions? Anything else somebody wants to share? Okay, a couple of announcements. Next month, July, our meeting will be on the third Monday as usual, July 21st. And we'll be doing our annual monsoon challenge. So hopefully you've been out there trying to beat the clouds and beat the heat and get an image from the constellation Ophiuchus, because that's the challenge for this year. to image something in that particular constellation. It's getting kind of late in terms of monsoon, where the heat's getting bad and the clouds are coming. So if you haven't gotten out there yet, you might want to get on it. But you got a month to go. So next, that'll be the July meeting. We'll share our monsoon challenge images. If you have an image or two that you want to share, please email me privately just to let me know that you want to participate, so I have an idea of how many folks to plan for. Also, if you're interested in having your images published in the Desert Sky Bulletin, you need to send those to me, or you can tell me just use any image that I post on the TAA forum. The images should be 10 megabytes or less, so we can handle them for the bulletin. And finally, if you have ideas for future meetings, we would certainly like to hear about those, because this is a group-oriented endeavor, and most of the times the stuff that you're hearing comes to you because someone suggested it to us. So again, if you have particular things that you think would be of interest to the group, or maybe just interest to you, but you'd like to hear others' opinions, please feel free to send those to either me or to Jeff.
And I would add, if you are interested in presenting a topic, we would like that just as well.
Absolutely. All right. Well, if there aren't any other questions or things to share, I'm going to call it evening. And again, Craig and Jeff, thank you for good in-depth coverage of how to get rid of those bad subframes.
Thanks, Craig.
Okay, everybody.
Night.
Bye.